Hi there, I'm Paul Belflam and this is Industrial Organization. This presentation is about price discrimination and competition. Our objective is to analyze whether and how competing firms resort to price discrimination tactics. You can find some background reading in the textbook, Chapter 8, Section 8.3. What we want to do is to address three research questions that have to do with price discrimination in competitive settings. So several firms have the possibility to use price discrimination, and the basic question is whether they will do so. Okay, so we start with group pricing. We have two competing firms. This is the model we are going to look at. They can choose to practice group pricing, but the question is whether they will do so. Okay, and we'll find situations where at equilibrium firms do actually practice group pricing, but they would be better off jointly if they could refrain from practicing group pricing. So we want to highlight this interesting result. We move next to geographical price discrimination, another form of group pricing, and we ask whether it's always a good idea. So here we will stress the result that firms may prefer to commit to some national pricing, so avoid to have different prices in different regions, and they will do so for strategic reasons that we will uncover. Finally, we'll say a few words about menu pricing in competitive context. We'll just look at some empirical findings and see that it's not clear how competition affects the practice of menu pricing. Let us start with group pricing and localized competition. We look at a specific model, which is an extension of the hoteling model that we have already analyzed a couple of times now. So let me just remember the main ingredients of the model. We have two firms. We simplify by saying that the marginal cost of production is equal to 0. And we locate these two firms at the extreme points of a line of a unit length, 0 to 1. Okay, so there is maximum differentiation. Consumers are uniformly distributed along that line. There is a mass 1 of consumers. And remember, they have a unit demand. So they buy one unit either from firm 1, which is located at 0, or from firm 2, which is located at 1. The net utility they obtain is as follows. R is the maximum willingness to pay a consumer has for her preferred product, but she has to content herself with a product which is not exactly what she likes, and so she has to travel, this is the word we use, to the location of the firm, either to 0, in that case a consumer located at X would have to travel a distance X, and this distance totally cost tau times X, so tau is the cost per unit of distance. Right? Same thing if she goes to firm 2, which is located at 1, then she would have to travel a distance 1 minus x, so the total transportation cost to go to shop 2 is tau times 1 minus x. Okay, and then to go, when they buy from either shop, they've got to pay the price of that shop. Okay, so you remember this is the basic formulation of the hoteling model. Now what we add is different scenarios about what information the firms have about the preferences of the consumers. Okay, in this model, the preferences are summarized by the location of the consumer. Okay, in the model we have looked at so far, this location is not known by the firms. They just know that the consumers are located uniformly between 0 and 1. Okay, but when one consumer comes, let's say, to shop 1, the owner of shop 1 has no idea where this consumer is located. Okay, now this is what we want to change. Okay, we will assume that firms have some information, better information about where consumers are located, and so we will assume that this information can be more or less precise according to the number of sub-intervals of the line 0, 1, the number of sub-intervals in which the firms can actually identify the consumers. Okay, so the measure of the quality of information is K, and K is just the measure of how many subintervals there are in the partition of the consumers. So let me make this much more clearly with a picture. So K is equal to 1 would mean that there are two segments. What does that mean? It means that the firms, firm 1 and 2, they know when a consumer comes to their shop or buys a product from them, they know whether this consumer is located between 0 and 1/2 or between 1/2 and 1. Okay, so in a sense, take the point of view of firm 1. Firm 1 knows whether a consumer is relatively closer to its shop than another consumer. So if this is a consumer coming from the first segment, firm 1 knows that this is a consumer who has quite a strong preference for firm 1. Okay, whereas if firm 1 identifies this consumer as coming from segment 2, then firm 1 knows that a priori this is a consumer who prefers to go to firm 2. Okay, so that's already better than just knowing that consumers can come from anywhere between 0 and 1. Now, you would improve information if you give the possibility to firms to know whether consumers are coming either from this first segment between 0 and 1/4, or between 1/4 and 1/2, or between 1/2 and 3/4, or between 3/4 and 1. Okay, so this is an additional knowledge that the firms would have if they can identify consumers according to these 4 segments. Okay, and it's even better if they can segment the whole line into 8 segments, and so on and so forth. Okay, so the better information is symbolized by a value of k, which is increasing, and you can see this as an increasing number of sub-intervals, sub-segments, within which the firms can identify the consumers. Okay, so that's the idea that we have in this model. Now, what do we analyze? It's a 3-stage game. Okay, in the first stage, firms will decide to acquire information of some quality k or not. Okay, so think of this information being available at no cost. Okay, but the firms still have to decide whether they use it or not. Okay, if they use it, well, there is an extra part in stage 2. So at stage 2, they choose their prices. Okay, but if they have some information, they can decide to offer a discount to some specific consumer segments. Okay, so they set a regular price, and if they know better where the consumers are, in which sub-segment they are, they can decide to offer to some segments a discount below the regular price. Okay, and then in stage 3, consumers decide from which firm to buy. Okay, so if we look at stages 2 and 2A and 2B, there are 4 potential subgames according to the decisions that have been made at the first stage. Okay, neither firms acquires information. Okay, so this is the Hotelling model that we have looked at so far. Both firms, all they know is that consumers are located between 0 and 1. They don't have more information than that. Okay, and remember, in that case, the price would be equal to the transportation cost tau, and as both firms serve half of the market, this is the profit they make, tau divided by 2. Okay, so NI here refers to the fact that firm 1 has no information and firm 2 has no information either. Okay, so this is one subgame. Another subgame is the subgame where both firms would use the information they have. And finally, we have 2 subgames where one firm uses information and the other firm does not. Okay, and so we need to find out which prices or price firms choose in any of these subgames. Well, we already know for the subgame where they don't acquire information. We need to look at these other 3 subgames now. Okay, so let's start with the situation where both firms acquire information. Okay, now firms know where consumers are coming from. Okay, they know whether a consumer is in this segment or this other segment, right? And so they are in asymmetric position. Firm 1 has an advantage in the subgames where consumers are closer to that firm, so between 0 and 1/2, and the opposite is true for firm 2. Firm 2 has an advantage for consumers that it identifies as being between 1/2 and 1. Okay. Now, if I'm a firm and I identify a consumer as being very close to my place, I certainly can get a high price for these consumers. Okay, and it's very hard for the other firm to attract these consumers who are located near to me. Okay, the other firm would have to compensate to such a difference in transportation cost that it's basically not possible to attract them. Okay, so this is very intuitive, and each firm has a clear advantage to attract consumers who are located near to them. Okay, now things are more complex for the consumers who are located in the middle. Okay, here both firms know that these consumers are relatively indifferent between the two firms because they have to travel more or less the same distance to go to firm 1 or to go to firm 2. Okay, so for these consumers, they will fight quite fiercely to try to attract them, and this is what we call poaching. Okay, so a firm would try to set a very low price, a strong discount, to attract these consumers who are just near the center, nearer to the other firm, but not that far for it to be impossible to attract them. Okay, so again, let's look at a picture. We take an example here where there would be 8 segments. Okay, so I recall what that means. It means that the two firms know that whether a consumer is coming from segment 1, segment 2, or segment 7 or 8 or whatever. Okay, so they know in which of each of these 8 segments a consumer can come. Okay, and so what we have at equilibrium is that firm 1 is going to attract certainly all consumers in 1, 2, and 3. Similarly, firm 2 is going to attract all consumers in segments 6 and 7. But for segments 4 and 5, which are close to the middle, there is what is called poaching. Okay, so look at these consumers here. They are in green, meaning that firm 2 is attracting them, although they are, in absolute terms, closer to firm 1 than they are to firm 2. Okay, and the same thing happened here. I've got a blue region here. These are consumers who are normally, I would say, at equal prices, they would go to firm 2, but firm 1 offers them a sufficiently large discount to attract them to firm 1. Okay, so when we have summarized and computed all this, we know what are the prices set at equilibrium, we can compute the profit of the two firms when they both have information according to the information they have. So K is the number of segments, if you want. Okay, so what we find here, if you do the math, you find that this profit is U-shaped in the sense that it actually decreases, or let's show it here, it's as this form, according to the level of information. If the level of information, so if K is small, the profit is quite large, then it decreases, then it increases. For even larger values of K, it will increase. Okay, and this is because there are two forces playing in opposing direction. There is higher competition for these consumers at the middle, and this is a very strong effect when K is low. Why? Because these segments around 1/2 are larger the fewer there are segments. Okay, but the other effect is that for these consumers who are close to the firms, there is no competition there, and it's possible for the firms to set high prices for these consumers. This is what we call surplus extraction. Okay, and that dominates for larger values of K. Okay, so what we find here is that nevertheless, the profit of the two firms when they both have information is always lower than the profit they obtain when none of them is using information. Okay, so this effect of higher competition decreases the profit of firms when they use information. Okay, so we already have there part of the result I was announcing before, that if they could collude, actually, if they could coordinate their choices, they would prefer collectively to not to use the information. Okay, but is this the result of an equilibrium of the whole game? We still don't know, because we need to look at games where one firm acquires the information and the other firm does not. Okay, so here I'm not going to detail all this. Okay, just show you what happens if firm 1 has information but firm 2 has not. Okay, well, firm 2 is still keeping the consumers who are close to it. Okay, but for consumers here, for example, in segment 6, it's already possible for firm 1 to poach them. Okay, so sorry, it's here, even in, sorry, I repeat, in segment 7, it's even possible for firm 1, which has the knowledge of where the consumers are. Firm 1 can offer specific discounts to attract these consumers. Okay, so clearly the firm that doesn't have information is at a disadvantage here, because this firm is setting the same price for all consumers, whereas the firm 1 here that has information has the possibility to adapt its prices with specific discounts to where the consumers are located. Okay, so we can again compute the profits of the two firms for a given value of information. The firm that has the information whereas the other one doesn't, and symmetrically the firm that doesn't have the information whereas the other firm has. Okay, we again have a U-shaped function, okay, and we find also that the profits of the firm without information decreases with the quality of information. Right, so I realize here that I'm not giving you a lot of details, but I don't want you to go into these details. I just want you to have the big picture. And this is what I want to show you now, moving to the first stage. So here, the firms have a dichotomous decision to make. Either they don't use the information or they do use it. Okay, and we find here the profits that we have sort of computed by solving the second stage of the game. Okay, so just to show you what happens, what equilibrium we have in this matrix, I depict here the evolution of all these profits with the quality of information. Okay, so recall again that K is a measure of how refined the information is. Okay, the larger K, the more subsegments can be made, so the more information the firm have, because they can localize they can identify from which segment of the line the consumers are coming. Okay, so when both of them don't use the information, this is what we have in the Hotelling game. Okay, so and the profit, of course, is independent of the value of information because firms don't use it. Okay, and this is tau divided by 2. Now, the profit when they both use information, remember, it's always below the profit when none of them is using the information, and it has this U shape. It decreases and then increases with the quality of information. Now, what we have in blue here, the dotted line, is the profit of the firm that uses information when the other firm doesn't use it. And here, sorry, in black, it's the profit of the firm that doesn't use information when the other firm uses it. Okay, so how do we find the Nash equilibrium in the first stage? Okay, so we take the point of view of a firm and ask what to do, meaning whether to use or not the information, given what the other firm is using. Okay, so take the first situation where the other firm uses the information. Okay, so this is comparing these two lines here. The other firm uses the information, okay, and I'm asking whether I should use the information or not. Okay, well, you see, if K is small, the black line is above the blue line. Okay, so it's better for me not to use the information, right? But if K is larger than, at least as large as 3, then it's the other way around. I prefer to use the information rather than not using it. Okay, so when the other firm uses the information, I will use it as well, provided that the quality of the information is larger than 3. And actually the same goes when the other firm doesn't use the information. So here we compare the two dotted lines. And we also see that when K is small, it's better not to use it, but when K is large enough, it's better to use it. Okay, so this is summarized here. If K is less than 3, not using the information is a dominant strategy. This is what firms choose, whatever the choice of the other firm. And the opposite goes when K is at least as large as 3, then using the information is a dominant strategy. Okay, and this is the result I was presenting at the very start of this presentation. If K is larger than 3, then both firms would choose to use the information, but, so they would be on this line here, okay, but we see that this profit is lower than the profit they would obtain if they were not using the information. Okay, so this is again a prisoner's dilemma. Firms end up at equilibrium choosing to use the information, but if they could coordinate, they would prefer not to use it. Okay, so in this case, a law that would prevent firms to use information and to practice group pricing, this law would actually be welcomed by the firm, the two firms. Okay. Now, we haven't looked at this precisely here, but I can tell you that consumers prefer this situation here. Consumers as a whole, right? Because there is extra competition for those consumers located in the middle. The fact that the firms know where they are located induces them to practice lower prices. Okay, and this is also why the reason behind the fact that they make lower profits. But from the point of view of the consumers, at least those located at the middle, this is good news. Okay, it's bad news for the consumers located near the two firms, because these consumers will pay higher prices than in the case where no information is used. Okay, but if you look at the total consumer surplus, so if you add up the surplus of all the consumers, then what is lost by some is more than compensated by what is gained by others. Okay, so let's just summarize the results. In a competitive setting, customer-specific information impacts firms in two conflicting ways. On the one hand, firms can extract more surplus from each consumer, but on the other hand, price competition is exacerbated. Okay? When the quality of information is sufficiently large, the former effects dominate the latter. Okay? So then firms use the information and price discriminate at equilibrium. However, they may well be better off if they could jointly agree not to use information. Right. That was the main part of this presentation. Let me now just say a few words about oligopolistic geographical pricing, and then we look at menu pricing. So what is geographical price discrimination? Well, imagine that you are a retailer and you've got a number of branches in different locations. Okay, think of Carrefour, Deleuze, think of IKEA, all these big chains. Okay, well, they have the possibility, if they want to adapt their prices to the specificities of each region. Okay, for example, if you realize that in a particular region consumers have a very large price sensitivity than in another region, well, you could decide to have a lower price in that region where the price sensitivity is higher. Okay, this is exactly the same idea as having a different price for students than for seniors. Okay, and this is observed in many industries. For example, in the car industry, different countries would have different prices for the same cars, or even within a particular country, different regions may have different prices. Okay, now the question is it always profitable to do that? Of course, there is the positive impact of being able to be flexible and adapt your pricing to the specificities of different regions. But, and this is what we want to sketch here, there may be strategic motives for which you would prefer as a firm to have a national price, okay, or uniform price on all geographical segments. Okay, why would you decide to do so? Of course, as we just said, you would lose the flexibility, okay? But you may win something else, okay? And here we need to remember that price competition for substitutable products is such that prices are strategic complements. Okay, what does that mean? Remember, it means that prices of different competitors move in the same direction. So if I expect my competitors to raise their price, I will react by raising my price as well. Okay, another way to say that is that the reaction functions in the pricing game have a positive slope. Okay, so why is it important to stress that here? Well, if one firm finds a way to commit to a high price, okay, so to convince its competitors that it will raise its price, then it's a good thing to do for your own profit, because this will induce your competitors to rise their prices as well. Okay, so price competition will not be that tough, and that would mean higher profits for both firms. Okay, Of course, the key behind this is to find a way to really make sure that you will increase your price. Okay, just saying it is cheap talk. It's not going to work. You need to tie your hands in some way and convince your competitors that your price is going to be higher. Okay, and this is exactly what a national price would mean. It would mean for some regions that this national price will be higher than the price that would be set if there was geographical segmentation. Okay, and that can increase profits in these regions in such a way that it would compensate the profit which is lost in other regions. Okay, so this is summarized here. Suppose that a firm is active on several market segments, with some segments being more competitive than others. Okay, and so if the firm is practicing geographical price discrimination, it would have large prices in the less competitive segments and lower prices in the more competitive segments. Okay, now what is the effect of commitment to setting the same price everywhere? Well, in these competitive market segments, the price will increase, okay, but that will soften the price competition in these markets and increase profits in these markets. Okay, of course, in other markets, it will, for the same reason, it will decrease profit. But if you can gain more on these market segments than what you lose on the other market segments, then it may be a profitable policy to set a uniform price. Okay, how can you do that? Well, like IKEA, for example, by publishing prices, distributing them in a catalog, which is valid for a whole country. Okay, so that shows that the company says, well, for whichever shop you go to, you will have exactly the same price. Okay, so this is a commitment to have a national price and so refrain from practicing geographical price discrimination. Here are just an example. In around the year 2000, there was an inquiry that was made by the UK Competition Commission, so in the United Kingdom, and they looked at supermarket groups and they found out that a bit more than half of them were pricing uniformly, whereas the other half were adjusting prices to local conditions. Okay, not for all products, but there were quite substantial differences in prices for some categories of products, up to 20% for some category of products. So if you were comparing the price in the most expensive and the cheapest region for the same chain of supermarkets. Right. Just a few words now about menu pricing and competition. The theory here is a bit more complex. I'm not going to go into that. Let me just mention a recent empirical analysis that was published in the American Economic Journal. So we know that price discrimination is very common in airline industries. Okay, so if you take a flight and you ask people around you how much they paid, they will give you as many different prices as there are different people. Okay, although this is the same product, it's going from one city to another. Okay, and so this is what they confirm with their empirical study. There may be up to 100 different fares paid by individual travelers, depending on where they are seated, when they booked, and other criteria. Okay, now how is this affected by competition? Should we expect more differences among travelers when there is a lot of competition on a given route, or less differences? Okay, so they looked at the Canadian airline industry and they got a nuanced view about this question. Okay, it seems that there is the biggest impact from competition in the mid-price range, so for these tickets that are not too expensive nor too cheap. Okay, whereas the fares at the extreme stayed the same, and those in the 15th and 75th percentiles of the distribution dipped significantly. Okay, and after, this is what we should have written here, they compare a situation where actually the competition has increased on the main airline routes. Okay, so let's look at this on the graph. Okay, so they say competition had a clear impact on the prices Air Canada charged to customers in Toronto, However, the impact was only on mid-price tickets. The cheapest and most expensive seats stayed the same. Okay, so this is the distribution of fares, and you see that there is a decrease for the middle, but not so much at the extreme of the distribution. Okay. So just to summarize here, the effect of more competition, so the introduction of more firms, for example, in a given industry, has quite nuanced effects on the prices and the practice of menu pricing. And this is all I wanted to cover with you on this specific topic. Thank you for your attention.